So we're going to be talking about trigonometric functions. In geometry, you were introduced to the three main trigonometric functions, which is sine, cosine, and tangent. And sine, if we are using angle theta right here, sine of angle theta is going to be equal to the opposite side divided by the hypotenuse. Cosine is going to be the adjacent side divided by the hypotenuse. And for tangent, we don't need the hypotenuse. We're only going to use opposite side divided by adjacent. An easy way to remember this is using SOHCAHTOA. Sine, so S, is equal to opposite over hypotenuse. Ka is cosine adjacent over hypotenuse. And tangent, TOA, opposite over adjacent. Apart from the main three, we also have cosecant, secant, and cotangent. Cosecant is related to sine, and we can see that instead of being opposite over hypotenuse, you only need to flip that fraction because it's going to be hypotenuse divided by the opposite side. For secant, you're going to get the hypotenuse divided by the adjacent. So instead of using cosine where the adjacent part is the numerator, now we have the hypotenuse. And cotangent is related to tangent, so the opposite over adjacent, you're going to flip it and you get adjacent over the opposite side. Oftentimes you're going to see this as cosecant is going to be 1 over sine. Secant is 1 over cosine. And cotangent is going to be 1 over tangent. The reason that they write it like that is because the fraction is just going to be flipped. We're going to go into how the trigonometric functions are applied in the unit circle. The unit circle is going to be a circle in the coordinate plane, and the center of the circle is going to be at the origin. We're going to say that the radius is 1 unit, and that's why we call it the unit circle, because the radius is 1. And the equation of the unit circle is x to the second power plus y to the second power is equal to 1. The x squared plus y squared equals 1 actually comes from Pythagorean theorem. We know that a squared plus b squared equals c squared. In this case, we have x squared plus y squared is equal to 1 squared, which is just 1. We know that the hypotenuse of any triangle inside the unit circle is going to be 1. To learn how to build the unit circle, we need to make sure that we know how to change degrees to radians and also radians to degrees. So to convert degrees to radians, the only thing that we're going to do is we're going to multiply the 50 degrees times pi over 180. We can simplify this a little bit. The 50 and the 180 have 10 in common, and that's going to give me 5 pi over 18. And that is your answer. Anytime that you're going to go into radians, you need to make sure that you leave it in terms of pi, unless it completely simplifies, but you want it in terms of pi. You don't want any decimal. You need to convert 6 pi over 7 to degrees. So the only thing that we're going to do in this case is we're going to get the fraction that we wrote in the other part, but we're going to flip it. So we are going to put 180 degrees over pi. You can cross cancel the pi's. Now 6 is not divisible by 7. 180 is not divisible by 7. So you're going to have to multiply 6 times 180. That's going to give us 1080. And you're going to divide by 7. In this case, we want a decimal form. And we get 154.29. We're going to round to 2 decimal places. In geometry, you learn about the 45, 45, 90 triangle, and then you also learn about the 30, 60, 90 triangle. And we're going to use those special angles to make sure that we are able to build the unit circle, or you're able to memorize it. But if you pay attention, at 30 degrees, if we were to multiply 30 degrees times pi over 180, we will get pi over 6. And you can see the same numbers that we saw in the special triangles from geometry. So we're just putting all that and we're connecting it. If you were to, again, change anything like this into radians, or if you were able to change those radians into degrees, you're going to get the same numbers. You are able to build it if you know the formulas, or you can just memorize it. And you can see that there's a pattern. The locations of the 6 are always 30 degrees away from the x-axis on both ends. You're going to see that the division over 4, it's always going to be in the middle section because you're 45 degrees away from the axis or from either axis. So those patterns can help you build a circle whenever you need to. This is the initial side. This is going to be your terminal side, and this is going to be the angle that we're dealing with. Now, we are going to use the trig functions to find specifically what coordinates these two are. We know that this is going to be your radius, r, and if you're trying to find your x value is going to be on the on your x-axis, your y value is going to be vertical. So if we're trying to find that, you can use different trigonometric functions based on the information that you have. So again, if we're paying attention to the sine of theta, you're going to get your y divided by your r, your radius. If you're going to do cosine, you're going to be paying attention to the adjacent part, which is going to be close to the x-axis divided by your radius. And that's how you're able to take everything out as long as you're given one single point. So we know that the point -4 and 3 is going to be on the circle. And it tells you to determine and evaluate the other 6 trigonometric functions. So the first thing that we need to figure out, what is r? And to find r, we know that x is -4 and y is 3. So the first thing that we're going to do is use Pythagorean theorem, and that's going to help us find our r value. So -4 square plus 3 square is equal to r square. And this is going to be 16 plus 9 is equal to r square, which is 25 is equal to r square. Find the square root, and you get r is equal to 5. And now to write all the trig functions, we're just going to start with the three main ones. So we have sine theta, cosine theta, and tangent theta. And based on the list that we had before, we know that sine is going to be your y value. Your y value, just coming from the coordinates, we know that that's going to be 3. So we have 3 divided by the hypotenuse, or r, that we already found that it's 5. So 3 over 5. For cosine, we're going to get negative 4 over 5. And for tangent, we're going to just do y divided by x. So we have 3 divided by negative 4. And to find the other group, the only thing you need to do is just flip it. So you're just going to do, and I'm going to put it at the bottom due to space. For cosecant theta, just flip sine. So that's going to be 5 over 3. For secant theta, we're going to do negative 5 over 4. And for cotangent theta, we're just going to put negative 4 over 3. In this case, we are dealing with something in the third quadrant, and you see that they're both negative. And we also need to find our r. So we're going to do 5 square plus 12 square, and that's equal to r square. So this is 25 plus 144, and that's equal to r square. 169 is equal to r square, so r is equal to 13. So we know that r right here is going to be 13. And now we're just going to rewrite all the trig functions. So sine theta, and that's going to be your y value. The y value right here is going to be negative 12 over 13. Cosine, you're looking for this value right here, and that's going to be negative 5. So negative 5 over 13. And tangent theta is going to be your y divided by your x. So in this case, it's going to be positive 12 over 5. And now, for the other three, for cosecant theta, let's flip it. So 13 over 12. Secant theta, negative 13 over 5. And cotangent theta is equal to 5 over 12. A crucial part to understand when it comes to the unit circle is going to be the values for x and y and how we get them. And for this, we're going to go back to geometry when you cover special triangles. When you have a 30, 60, 90 degree, and when you had a 45, 45, 90 degree. And this is where we get this table. This is where all the tables derive. Because originally you saw that if you had a 30, 60, and 90 triangle, the small section, the small leg was going to be x. The hypotenuse was going to be 2x. And the long leg is going to be x root 3. And the same thing applies to the 45, 45, and 90. In that one though, instead of being 2x or x root 3, you actually have the smaller sections are x, and the large section, the hypotenuse, is going to be x root 2. This is where these numbers are coming from. And you're able to use that to fill the rest of the table. If you're able to remember the first three functions, sine, cosine, and tangent, you're able to remember the rest because the only thing that you're going to be doing is flipping it. So you're going to do the reciprocal. And you need to make sure that you know which quadrant you're using. If it's in the first quadrant, your x's are going to be positive, your y's are going to be positive. If it's the second quadrant on the unit circle, only your y's are positive, but your x's are negative. You go to the third quadrant, both of them are negative, so that's when tan becomes positive. And then for the fourth quadrant, you're going to have your x values being positive and your y values being negative.